Welcome to the Stormsurf Video Surf Forecast of the week starting Sunday, January 20th. Looking at significant wave heights for the North Pacific Ocean, we see a gale in the western Gulf with seas in the 36 to 38 foot range, but most of that energy is pushing off to the northeast. We also see another gale in the far west Pacific Ocean with 34 foot seas aimed pretty well at Hawaii, and that is generating swell pushing towards the islands. Let's get into all the details. As usual, we'll start our tour looking at Jetstream level winds. These winds up about 30,000 feet help support the formation of gales. When they do form, help direct their track. We're looking for a trough or a dip in the jet, just like right there. Actually, we have a pretty good pattern going on here. Winds are 190, almost 200 knots pushing off Japan. The jet's well consolidated, falling into this little trough here. That helps create a counterclockwise flow aloft, sort of in the eddy here in the atmosphere and down to the surface. Of course, that's the hallmark of low pressure. Low pressure generates wind. Winds generate seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, turns into surf. So we have a pretty good pattern here in the West Pacific. But in the East Pacific, you can see the very beginnings of a split in the jet. That is, the northern branch heading up this way, the southern branch heading this way. And typically when that happens, the area in between the split turns into high pressure, and high pressure does nothing to produce swell. Also notice we have a little bit of a trough here in the northern branch, just off the Pacific Northwest coast. That's also supporting low pressure development, and that is creating rain and weather into northern and in parts of central California, and maybe some snow for the Sierra, but nothing really in terms of surf. All right, let's put this into motion and see what happens. So you can see the jet stream, if anything, starts building as we get into Monday with a broad area of 200 knot winds pushing off Japan. The trough kind of dissipating a bit west of the date line. And then winds actually build there to 210 knots on Tuesday, then fade in a little bit. But the pattern, the split, becomes very obvious. In fact, let's go back and you can just watch it. This split evolve from here. You can just see opening up, and then we're into, I believe, Wednesday. There you go. Broad split, high pressure. So this will be a significant weather change for California, where previously we've been under the active phase of the MJO. That's been driving energy into the jet. The jet's been consolidated the whole way across the Pacific, pushing storm after storm into California and the Sierra. That pattern will end now, and that's all attributable to the inactive phase of the MJO setting up in the West Pacific. So you can clearly see the difference between the active phase and the inactive phase and how it interacts with the jet stream. And then the jet stream, in turn, interacts with the lower levels weather pattern and creates, in this case, clear and blue skies for California in the future. All right, but meantime, in the West Pacific, jet still consolidated 72 hours out, and let's see where it goes from there. Another trough starts building on Thursday on the west side of the split. Jet still remains solid, but well split east of there. And then as we go out even further into Saturday, jet still looking very solid, 180 knot winds pushing over the date line into the split, but just not budging from about 155 west or so, and then into Sunday, we're talking a week out, new trough starts building off Japan, and then almost a trough trying to build here. We suspect the split will redevelop just north of Hawaii and continue the high pressure lockdown of California. So just looking at the jet, the pattern very much looks like storminess in the west, high pressure, blue skies in the east. So let's go down to the surface. Surface level pressure, surface level winds, and as expected, yes, a gale low here in the western Gulf, generating 45, almost 50 knot winds, and that's generating seas. And we see a rather stormy pattern here in the West Pacific with fetch. We'll see how that evolves. But we also see high pressure starting to develop. Here's the low pressure, a very weak low pressure, sweeping into Northern California. And here's the area of high pressure that's expected to build in the days ahead. As we get into Monday, the low dissipates, moves off. Another gale tries to develop west of the date line with 45 knot northwest winds. High pressure building to 1032 millibars off of California. This is Monday night. North winds in control. The first gale sort of weakens, another fetch, 35 knot winds, builds on the dateline. High pressure starts ridging into the Pacific Northwest. And then we continue on. Gale, just continued sort of a weak gale pattern because there's not a lot of troughiness in the jet stream, even though the jet stream itself is strong. But as you get into Wednesday and Wednesday afternoon, high pressure in control the whole U.S. West Coast from British Columbia southward, and another gale starts building off Japan. That one gets a little bit more footage with 45 knot winds as we get into Thursday, and 50 knot winds into Friday, pushing towards the dateline. And then starting to lift north. Remember, the jets, the northern branch is up here, so it just directs everything up into Alaska. And then the system over the dateline starts lifting north, fading out, and yet another system tries to develop off of Japan on Sunday, not doing anything very dramatic. And there we go, 50 knot winds as we get into Sunday night. That's a week out, and high pressure, again, in control of the U.S. West Coast. So the pattern remains storminess mainly west of the dateline, high pressure east of the dateline. So good conditions for the U.S. West Coast, and Hawaii for the most part. Swell, small, longer period, groomed, radiating to the east. So that's better than storminess and south winds. All right, so let's take a look at the wave models. What's the effect of the winds on the ocean surface? As we saw before, 36, 38-foot seas over a small area in the western Gulf of Alaska, mainly all aimed off to the northeast, but some small swell is expected into California come Wednesday or so. And this system was actually a little bit stronger off Japan 24 hours earlier. It's also generating swell targeting mainly Hawaii, but some of the energy from this will also make its way into California. These systems fade out, and then you begin this pattern of just steady, small, tiny area 32-foot seas approaching the dateline on Monday night, another one behind that. But what you get, this is just sort of a continuous wave machine, continuous seas in the 24-foot range, let's say, generating 14, 15-second period swell, just pushing both towards Hawaii and the U.S. West Coast, till we get into Thursday night. A little bit stronger system develops off Japan with 34, 35-foot seas. That'll get you a little bit more period. This was actually progged to be much stronger, but is now fading out, not looking at much different than any of the others before it. And then finally, as we get a week out, one tiny little system. So the nutshell of all this is small, rideable, approachable surf for Hawaii and the U.S. West Coast with decent conditions, but nothing over the top. Just surf for normal mortals while high pressure takes over and no snow for the Sierras. Let's do a quick look at wind conditions for both the U.S. West Coast and Hawaii. By Sunday, here's this low pressure system that's generating rain pushing into California coast. High pressure behind it, gradient between the two, starts building northwest fetch, and that pushes in to the U.S. West Coast by Sunday night. Pretty good west-northwest winds driven by, we'll call it clearing high pressure, south winds for the Hawaiian Islands. So we get into Monday, north winds continue driven by high pressure, south winds continue for Hawaii. So we get into Tuesday, then the high starts ridging in. You can see a big high inland, high pressure here. That's going to set up a offshore flow, and that will dictate the pattern for the U.S. West Coast for the coming week. Meanwhile, south winds for Hawaii, right, flowing around clockwise around the high pressure in the northern hemisphere. Southeast to south winds, let's say, which isn't bad for north-facing shores. And you can see here we are into Wednesday. It's a light offshore flow specifically for most of California and a southeast flow for the Hawaiian Islands. You can just see it's like this big wedge right here, just protecting all this area from any inclement weather, offshore flow. And Thursday and Friday. Now notice a front pushing into Hawaii. We'll actually go back. Approaching Hawaii, it's really driven by high pressure, though, not low pressure. North winds look poised to impact Hawaii, and they do as we get into Friday night, where we have an offshore flow for the U.S. West Coast. More of the same into Saturday, north winds for Hawaii, and then into Sunday, some sort of a cutoff low here continuing the north wind pattern for the islands, but the offshore flow for Hawaii. We'll see, and there we go, right out to the end of it. Really no change for the U.S. West Coast, and really not a great setup later in the period for Hawaii. Next up, we'll look at precipitation for California, and the striking effects of high pressure here will become apparent. Here's the last little low pressure system. Snow forecast for the Sierra as of 18Z Sunday. That was about 10 a.m. Actually, snow started in the higher elevations of Sierra about noontime or so. Supposed to get pretty solid overnight. Good dosing of snow and light rain for the U.S. West Coast, mainly down to Point Conception. By Monday morning, everything clears out. High pressure rules supreme, and then you just see it's a bulletproof dome of high pressure. Really, nothing gets into California. Nothing even gets into Whistler and British Columbia as we get into Friday. And that pattern just gets reinforced with a 1038 millibar high as we get into Sunday. And really, this is all the effects of the inactive phase of the MJO. So a couple of week break possible in terms of snow and weather for the U.S. West Coast. A quick look at snow forecast projections. We'll start at Squaw Valley from this last little system. Total accumulations Prague to about 28 inches or so, and then you see absolutely no precipitation forecast. This is the 10-day GFS model too. You can also look at snow levels. Yes, here they are. The red is liquid precipitation. The gray is sleet. The white is snow, and the blue is enhanced snow. You can see into 12Z today, and then by about midday, you see snow levels going down. This is the bottom of Squaw Valley, the valley floor. This is the top of the peak of the resort. You see snow levels dropping solid. Here's your precipitation spike. But then as we get into, in the evening of the 21st, snow levels rise dramatically. Not that it matters because there's no precip forecast, but you see warm weather taking over even in the Sierra. Wind gusts. Yeah, a bit of winds with the passage of the front. Then things really settle down. High pressure takes over, domed up right over California. Quick look at Kirkwood. Basically the same story, 26 inches and then nothing. Temperatures, same deal. Freezing levels above the summit at Kirkwood. And wind, pretty much the same situation as well. And we'll take a quick look at Mammoth. Not as much snow, maybe 10 or 11 inches, something like that, but then the same temperature profile and pretty much the same wind profile. So all the data seems to be in good agreement. All right, let's take a look long term. What's going on with the MJO and supposedly our El Nino? The good news is the TAO buoy array site is back up and running. That is great. Now we can examine winds as we like to do over the Kelvin Wave generation area. This is the West Pacific here, East Pacific here. This is the equator. There's New Guinea. Kelvin Wave generation area from 170 west, 5 degrees north and south of the equator, going the whole way back to 135 east, pretty much the equatorial West Pacific. When you see westerly winds there, and you see a little bit of hint of that, that suggests perhaps the active phase of the MJO, and if it persists long enough, that would suggest El Nino. But right now, we're looking at winds. So these are from the TAO buoy array, series of buoys strung across the equator, used mainly for measuring, monitoring El Nino, but it works pretty well for the monitoring the MJO as well. We see easterly trades in control everywhere except for this small little area south of the equator in the Kelvin Wave generation area. Looking at anomalies, differences from normal for this time of year, we say, yeah, the winds are pretty strong from the east, and they're a little bit stronger than normal. That's what these easterly arrows suggest, but not markedly so. And then you see when you get into the Kelvin Wave generation area, winds are actually from the west, suggesting, maybe some hints of the active phase of the MJO. Let's dig a little deeper. What have winds been doing the past 5 days? Well, we can look at this. CDAS 850 millibar wind anomalies. Kelvin Wave generation area right there. There's New Guinea. This is the equator. South America. Philippines. So Kelvin Wave generation area. Draw a box in your mind right around here. See westerly anomalies. That was on the 14th, the 15th, the 16th, the 17th, and the 18th. So there's been westerly anomalies in, we'll say, the western half of the Kelvin wave generation area, because it covers this whole area, but then a little bit of easterly anomalies, maybe in the vicinity of the dateline. Let's dig deeper. So here's winds for the whole planet on one chart. The dateline runs right up the middle. The Pacific runs from about here over to about here, Kelvin wave generation area from here to here, and you just sort of draw a line right up through here, and you can say, okay, here's past history, and you see the reds, that's westerly anomalies, and you can see they've been in control since before Christmas, all over the Kelvin wave generation area, active phase of the MJO, but now here we are, January 20th, you see blues in at least the eastern half of the Kelvin wave generation area. That suggests perhaps the inactive phase of the MJO. And as we go down over the next week, they're supposed to get pretty solid for the next 5 days, for the most part almost filling the Kelvin wave generation area. And then maybe westerly anomalies try to return a little bit, so Kelvin wave generation area from there to over to here. So half of it full of westerly anomalies, half of it full of easterly anomalies. So not a particularly optimistic forecast here, but not horrible either. So let's go take a look at the forecast 15 days out. So this is outgoing long wave radiation. That means the amount of sunlight bouncing off the ocean surface. The oranges and yellows suggest more sunlight reflectivity, meaning high pressure, meaning no clouds, meaning the inactive phase of the MJO. So this sort of suggests the inactive phase of the MJO is sitting right over the dateline, and that's where the easterly anomalies are. Makes perfect sense. Here's the active phase of the MJO over the Maritime continent. So basically not even really in the West Pacific yet. You go for the next 5 days and you see inactive phase starts easing off to the east. Active phase starts redeveloping in the West Pacific. A week out, active phase of the MJO is supposed to be filling the Kelvin wave generation area, and continuing into 2 weeks out per the statistic model. The dynamic model says basically the same thing. I'm just looking at the last frame here. The only difference is it suggests the statistic model says the active phase is to be a little bit stronger than the dynamic model. But in either case, 2 weeks, they'll say even a week from now, the forecast is supposed to be getting much better. So what's that mean? With the active phase building, the jet streams will probably be getting more energy in it, and the split over the East Pacific as the active phase moves east. See, there's the inactive phase. That's about where the split point starts, right? It's a little bit maybe displaced some, but by about a week and a half to 2 weeks from now, we think the split will be starting to fade, and then that could potentially usher in a return of precipitation to California. So maybe only a 2-week break at best, and then we're back in business for the snow. Looking at phase diagrams, so assume you're looking down on the North Pole. That circle there is the North Pole. And the MJO, both active and inactive phase, move from west to east, from the Indian Ocean, over the Maritime continent, over the West Pacific, under the United States, across the Atlantic, over Africa, back into the Indian Ocean. The heavy dot is where the active phase is right now, so almost centered in the Maritime continent. And the green line is the forecast of what it's supposed to do. The further away the dot is from the circle, the stronger it is. So it suggests a building active phase in the next 2 or 3 days, moving over the Maritime continent, and then moving into the West Pacific, but then weakening and really weak 2 weeks out. That per the ECMF model. The GEFS model says basically the same thing, but not moving quite as far to the west and maybe not quite as strong. The upper level model goes out 40 days and is about a week ahead of what's actually going at the surface. Where you see greens, that's the areas favorable for precipitation. There's New Guinea, there's the equator, there's South America. Yellows and oranges are areas not favorable for precipitation, so one could assume that to be the inactive phase of the MJO. This could be the active phase. And what you see is, and remember the split jet stream is roughly right around in here. Inactive phase supposed to be fading out by January 25th or so. Active phase building in the West Pacific, making its way across the Pacific through February 14th, and then another inactive phase develops in the West Pacific about February 9th, and it too makes its trek across the Pacific into March 1st. And then the 1 month CFS model, so it's showing something a little bit different. Again, this is the whole planet on one chart, Kelvin wave generation area between this tick mark, and this one here. So going straight up. So you see westerly anomalies in the West Pacific, West Kelvin wave generation area. Inactive phase right there, that dotted red. Actually, no, equatorial Rossby wave, sorry. Here is the inactive phase of the MJO here, but all sort of by extension, taking over the Kelvin wave generation area for about a week. Easterly anomalies continue, though, per this model. And then finally, as you get into the second week of February, you finally get some westerly anomalies redeveloping in the Kelvin wave generation area. So this model is a little different. It's suggesting favorable terms for about a week, then things fade out for about 2 weeks, and then as you get into the middle of February, things wake up. Interesting. And then finally, the 3 month CFS model. This one in reverse, though. This is past history here. Kelvin wave generation area between this tick mark and this tick mark, and you just work your way up. See yellows, that's all westerly anomalies. Looking at the forecast, you see not as robust a pattern, but still westerly anomalies forecast. Let's overlay the MJO. Here you go. There's our active phase of the MJO, all but gone in the Kelvin wave generation area. Here's the inactive phase of the MJO. It's supposed to have an effect, but kind of die into January 28th or so. And then, yeah, supposedly an inactive phase. I assume that's sort of a continuation of this one here, moving off to the east, but very weak. Westerly anomalies dying. They don't return till February 13th. And then a new active phase builds. Westerly anomalies build somewhat and continue. This is still a more favorable pattern than at any point last year, though it's not as good looking as it was earlier in the season back in here. And then let's overlay the low pass filter. So you see here, so this is basically an area supportive of low pressure development, like a broad pool of a tendency towards low pressure. 3 contour lines into December 19th, then it faded. This is what one would call El Nino, but we don't have El Nino. And the eastern edge of that pushing into California, expecting to continue into about, somewhere around the end of February, and then it retracts from the coast. Well, one would think that might be sort of where the tendency towards precip into California starts fading, but then you have the active phase of the MJO, so that will probably extend it a little bit further. But after that, the low pressure bias becomes focused mainly in the dateline Kelvin wave generation area, and supporting westerly anomalies, but nothing marked here, kind of just a almost return to normal pattern. So no clear indications of any El Nino development here. All right, we also have the subsurface temperature chart back again now. The TAO buoy array site is up. West Pacific here, East Pacific here. These are the anchor lines on the TAO buoys strung across the equator. The X's are the sensors on the buoy lines. That helps give you raw data. Then you use a model to fill in the gaps in between. What this suggests is warm water in the west, 30 degrees centigrade, and then warm water continue the 28 degree isotherm line has retracted some. Last time we saw it was somewhere over around 160, 155. It's back to 165 west, but the 24 degree isotherm continues to push into Ecuador and even a little deeper than it was before, suggesting more warm water pushing east than is normal compared to normal. In fact, here we go, anomalies, differences from normal for this time of year. All right, so what we see is a ball of warm water under the dateline down about 150 meters at 3, almost 4 degrees centigrade above normal. This appears to be a new developing Kelvin wave from the westerly anomalies that were blowing the whole month of December into early January in the Kelvin wave generation area, which is right around in here. So what that does is takes this warm water here, starts pushing it to depth, and then you get warmer than normal water under the dateline, and that will continue to push east over a 3-month period. In fact, and that's called a Kelvin wave. Here is the remnants of a previous Kelvin wave number 2, still pushing into Ecuador. But notice you have continuous warm anomalies, 1 degree or greater, from the filling the entire Pacific at depth, meaning there's basically a river of warm water, not particularly hot, but warm water, pushing off to the east. Clearly, there's no sign of La Nina anywhere to be found, and if one were eyeballing this, one might almost say it looks like El Nino. But there's more to the picture than just westerly anomalies and warm water moving east. We'll get into that in a minute. Here is another view, same data, modeled a little bit differently, but basically paints the same picture. Warm water here in the East Pacific, pushing in and erupting to the surface in this area from Ecuador to about 135 west. And then another Kelvin wave oozing off the Maritime continent, building under the dateline, getting ready to make its 3-month trek across the Pacific. This is all good news because warm water on the equator, especially in the East Pacific, also helps fuel the jet stream and helps fuel the storm track. That's part of what's going on. There's been this persistent pattern of warm temperatures and warm water in the East Pacific for a couple months now, and that's what has been fueling everyone talking about El Nino, though we know that's not actually developing, but still feeding the jet stream just the same. We have had an unusually stronger than average jet stream flow for certainly the entirety of this winter so far. Sea level anomalies. So this is here's South America. There's New Guinea there, Mexico, Maritime continent. So what you see is positive anomalies. So what that is, this is from the Jason-2 satellite. And what you do is strip out all the waves, strip out the wind waves, strip out the tides. It shows basically a 10-centimeter bump on the ocean surface right here, right at the intersection of the dateline and the equator. And what that means is warm water at depth, of course, expands, so that's what's creating the bump. So it's saying there's a bump of warm water or a pool of warm water here, a pool of warm water at about 120 west. So these are the two nodes. Kelvin wave number 2 here fading, Kelvin wave number 3 here building. And here's yet another view of how to historically view the warm water flow. A year ago, here was what we'll call Kelvin wave number 1, warm water from the West Pacific to the East Pacific. Here's the remnants last winter of our La Nina, cool water, the blues, the reds are warmer water. Kelvin wave number 1 pushing east, took a while to make it. Finally, in July, arrived on Ecuador, upwelling phase of the Kelvin wave cycle. Then as we got into September, October, westerly wind bursts in the West Pacific made Kelvin wave number 2, main node of it there. Wasn't even a distinct Kelvin wave, we'll say another pulse of it in December right there. And now we have what we think is building Kelvin wave number 3. So you can see 1, 2, and then here's Kelvin wave number 3 starting to develop under the dateline today. So not a bad pattern. You can see warm. Here's where we were last winter in February. Cool water over pretty much from the dateline east. Now it's warm water, and some of it pretty warm in pockets, and continuing for the foreseeable future. So we've talked about the MJO, we've talked a little bit about El Nino, we've talked about westerly winds, we've talked about Kelvin waves, we've talked about subsurface temperature profiles, but what really matters is temperatures on the surface of the ocean and their interaction with the atmosphere above them. So what's going on the surface right now? Well, amazingly, we have a pretty good eruption of warm waters here from Ecuador the whole way out to about 120 west, so that'd be about south of California. See this warm area there? That's actually new, stronger than what we've had for a month or so now. We also have warm water off of Peru, and this is kind of looking a little bit more like the typical El Nino triangle, but we still have this big pool of cool water here off of southern Peru and Chile, kind of limiting what can happen here. Still, this is feeding the jet stream, just not markedly so. Then you can also go out to the Maritime continent here, you see, and here's New Guinea, and here's the same warm pool making it the whole way to the dateline and beyond. So pretty good expanse of warm water warmer than normal water over the entirety of the Pacific equatorial region. The trend for the past 7 days, light warming off of Peru, marked warming, though very small in coverage from, we'll say, the Galapagos out to about 115 west, something like that. So, yeah, some warming, but you also see some pockets of cooling interspersed here. So kind of a mixed bag, nothing clearly indicative of El Nino, nothing indicative of La Nina either. And then the overview picture, again, here's our warming over the entirety of the equator, somewhat suggesting El Nino, but you would want to see a much larger signal in this area here than what we see. We see light warming at best in the 0 to 1 degree range, maybe a couple of pockets of 2 degrees here, but nothing really strong, nothing that really gets your attention. In fact, here's the temperature trend in the Nino 1.2 area, which is the area around the Galapagos, Ecuador, down into Peru. Temperatures today are 8.884 of a degree above normal. That's kind of interesting, but you see it's an upward trend. It was much higher, took a crash in late December, trying to rebuild now, but that's not the official Nino monitoring region. This is the Nino 3.4 region, which is from 120 west or south of California out to about the date line. You see temperatures have been hovering for months, about half a degree above normal, maybe a little bit more. We'll call it 0.6 of a degree above normal, and then they kind of dropped off in late December, trying to rebuild now at 0.749. So official El Nino is declared when you're for 5 months above the half a degree mark. We're not there yet. I think we have about another month and a half to go. And even if we were there, it would be at best a very, very weak El Nino. But El Nino is not just based on water temperatures. The atmosphere above that water has to respond. And so one way of measuring that is using the Southern Oscillation Index, difference in pressure between Tahiti and Darwin. When the index, the daily contribution is positive, that suggests higher pressure over Tahiti, lower pressure over Darwin, and that is not El Nino-like. Today's value, 5.28, and you go look back. We really want to see like that -20. You want to see that for days on end if you were in an El Nino or even a strong active phase of the MJO. We're not seeing it. We're seeing, if anything, sort of a weak La Nina thing here, but this is kind of noisy. So you go to the 30-day average, it just averages out 30 days worth of data, -0.69. So what's that saying? That's saying basically we're dead neutral. Not El Nino, not La Nina, just hovering right around 0. The 90-day average really used for a better idea of looking for El Nino is positive 2.66. If it was El Nino, it should be like -10 or -8. We're nowhere close to that. So if anything, this suggests neutral, biased, lightly La Nina. So what this is saying, the atmosphere thinks we're in a neutral pattern, irrespective of how warm the ocean is, what's going on with Kelvin waves. All that cycle is just limited to the ocean, and it hasn't had any impact on the air above the equatorial Pacific yet. And then one other index, the ESPI index, basically does the same thing, but it's measuring the amount of rainfall over the ocean north of Darwin, Australia, and over north of Tahiti. When the index is positive, that means there's more rainfall in here, which would be like El Nino. And when it's negative, it means less rainfall in there, which would be La Nina. Right now, the value is plus 0.27, or basically dead neutral in this region. Just the weakest indication of a little bit more rainfall in here than normal. So both the atmospheric indices are telling us there's no El Nino present. And then finally, the forecast, the official CFS version 2 forecast for the Nino 3.4 region. These are sea surface temperature anomalies. As of January 1, temperatures were estimated about, about 0.65, maybe 0.7 tenths of a degree above normal. Now, here's the good thing. The forecast, this isn't sort of El Nino-like, but the interesting part is temperatures are supposed to, we know actually temperatures are down a little bit lower than this, but temperatures are supposed to build to, let's say, 0.85 a degree. And whether you believe that or not, it's sort of immaterial. But what the interesting part is, the trend suggests that these temperatures are to hold, if not build, to 1 degree above normal as we get into October of this year. So what's that? 9 or 10 months from now. So we had been talking in earlier forecasts about the potential for a multi-year warm event. And according to this model, that's exactly where we're heading, and that's a really good place to be. Because what that means is, yeah, we're not in El Nino. That's good, because typically if you get El Nino, then you get a crashing La Nina after that. What this means is we're in this sort of steady state, slow warming thing, and that it might continue into next year, and it could even continue into the year after that. What that does is put steady, slow pressure on the jet stream, building it year after year. Once you get that momentum going, it's really hard to shut it off. It takes a big bulldozer pushing against it to shut off the jet. So what this means is, well, okay, we've had some pretty good surf this winter. Not epic, but not horrible. It's, I'll say, a little bit above normal. We were rating it as on a 1 to 10 scale, a 6, with 1 being horrible and 10 being great. This year we said a 6, and that's about what it seems like it's shaping up to be. This continues and we get this sort of pattern, that might push us into a 7 for next year, or maybe even a 7.5. So there is long-term benefits from a surf and a rain perspective if this pattern bears out. It also might suggest that the PDO is moving into the warm phase, as we've surmised it's been doing for a couple of years now. This would be further evidence of that, but that's a discussion for another day. So for now, looks like the rain and weather machine is going to shut down. Snow for the Sierra, cutting off for 2 weeks, probably, something like that. But the good news is we're going to get an offshore flow for California, good weather, and there appears to be a moderately frequent gale pattern forecast for the West Pacific. For the Western Pacific, which would result in long-distance swell energy pushing into Hawaii and California, making for smaller but rideable and groomed surf, something, that everybody can enjoy, which would be a good thing. And, warming temperatures, nice, pleasant conditions, a little bit of a break from winter for a week or two. But the expectation is, if the active phase rebuilds, then we're going to be back into a stormy pattern in 2 weeks out. And beyond that, well, maybe a multi-year El Nino, something to consider. So that's it for this week. Please excuse the raspy voice. When you get sick, you can't help it. And so that's where I'm at. Anyway, we'll do this again next week, same time, same channel. Thanks for watching.